Hi again. I figured since I was talking about framing, I'd talk about the foundation and foundation setup. I've done a foundation here for that same basic cabin we were looking at before. I left Helen in here so you can see kind of proportionally how big things really are. So what I've done is a crawl space foundation. There's different kinds of foundations. If the stem wall, which is this portion for those of you that have not had CAD before, or architectural design before, that portion right there that I highlighted in blue is the stem wall. It is, in this case, a 4-foot stem wall. Okay. Um, that gets us enough room for a crawl space underneath and to get below frost depth. Now, there's certain building code requirements and things that go into this. That's to be discussed later. But what you need to know is that the wood right here above that blue line, there's a little piece that's called a mud seal. And that mud seal is either pressure treated lumber or redwood in our area. Usually we use a lot of pressure treated around here. And that mud seal is literally there to separate the lumber from the dirt work. You've got to have at least 8 inches of clearance before you have any lumber. And so we've got to go from the top of this down 8 inches. Then we'll have the dirt backfill against this, and that's our foundation in the ground. And that foundation has to go deep enough into the ground that during the winter months when we get some frost, the frost doesn't get below it and cause heaving, which causes the ground to change depending on the water content and ends up breaking buildings. You can see some examples of it in our area if you go looking around, but this is the framing of it. So we've got a footing we pour first. That's a monolithic pour. Basically what we do is we have the contractor come in and he puts down a 2-foot wide channel between some usually 2x10s or 2x12s, and then he pours concrete in it, and he's got 3 number 5 rebar in there at least typically. And that's usually kind of in a V shape, a broad out V. So they go through this footing all the way through it, and they're continuous. And then coming up from them at every 24 inches, we have an L-shaped piece of rebar that comes up out and goes into the stem wall when we pour it on top. So they pour this, let it cure, because concrete doesn't dry, it actually cures. And then they come back through and put the forms on top of that and pour the stem wall on top of it. The stem wall is typically between 8 and 10 inches thick. Usually around here we see a lot of 8 inches, some 9s. And it's just normal concrete, usually like a 5 or 6 bag mix. So they put that in, and then at the top of it, while it's still basically liquid, they come through and every 24 inches they put in a J-bolt. It's a 10-inch J-bolt with a 4-inch washer. It's 1/2 inch in diameter. And they put the washer on, they crank the nut down to where they want it to sit in the concrete, and then they push it in and let the washer support it on the surface of the concrete until it cures. At that point, they then undo that bolt, that nut, take the washer off, cut holes in that, and set this mud seal into it. Okay, drill holes in the mud seal, line up the bolt holes, put that on there, and then they bolt the mud seal down, and then everything gets nailed to the mud seal. Now, there's one other piece that I didn't draw in here because I was trying to decide how to depict it in this. At every corner of the building, we have a hurricane strap or tie. It's basically a big piece of metal that comes up. It's about 3 inches wide, and it goes into the concrete down here and ties into the concrete itself in the metal, and then comes up and out and then gets nailed to the sides of the building, the corners, so that the building is securely fastened to this foundation. It can't be lifted off and say, like, any conditions really. If it comes off there, it's pretty catastrophic to the building. Okay, now let's look at some other things. I put the rim joist in. A rim joist is the same height as a floor joist. The floor joists are these guys right here. Okay, and they are manufactured floor joists in this case. They're basically wooden I-beams. And if I could turn one, actually, let's see if I can lift one up. I'm going to move this guy up a little bit. So let's pick him, move him up. There we go. Come on, I want to go on the blue axis. There, we can look at the end of him right there. He's an I-beam. So what this is just usually a piece of wafer board, and this is some laminated veneer lumber. And then they're cut and strapped together, and they're shoved out in like 40-foot lengths, okay? What that means is this. It's much more stable, it's much more even and consistent than natural dimensional lumber. There's very, very little variation by comparison. So we put those in. Now, usually we look at the span table that go with these. Span tables say 25 feet is the maximum span you can take. I don't like to go 25 feet. If I can do something earlier, I do. I've actually framed this in a couple of awkward ways just to illustrate a couple of points I wanted to illustrate. First off, this is a spread footing that goes through the foundation. It's part of the original footings. And then I put a wooden, basically bearing wall on it. It's just a short wall. It's a stub wall that holds up these joists. So that way they're bearing on the ends, and they're also bearing in the middle. So it takes that sag out of it. If you're ever in a wooden framed house and you jump up and down the floor, depending on your mass, sometimes you can actually feel the floor kind of give a little bit, and depending on the spans of the joists. So as we're putting those in, we figure out how many of those we need and what spacing we need. Now, spacing, like with other framing, gets changed around a little bit. This one, it fell right here, but I needed to make sure I had enough bearing on the ends, so I just changed a couple things up, added a double there. There's actually a triple here that lines up with another stub wall, and then some T-bones into it. Reason being, I wanted to see I can do just a straight strand there and a straight strand there, and that way I only have a few oddballs to put in. But we do have to have enough bearing on the ends, so sometimes we have to double them up and things to make sure we get enough bearing on it. That all gets done by a qualified engineer or to the manufacturer's specs if the manufacturer has spec'd it out for the building, which means they've involved an engineer in it. They all know what's going on. Now, one thing I do want to point out here, these joists do have allowable cut tolerances. So the bathroom in this building goes right here. Well, that means if I put plumbing in it, I've got a drain that's going to go down right through here somewhere, and it's going to cut through some of these. So I want to make sure I don't cut through too many of them. I don't want to basically cause these to fail because I cut through them. So I drill a hole just big enough for the pipe and put it through it and make sure that it's at the right angles and things. Those kinds of things are not difficult to do, but we want to minimize it. If I could do this a different way, I'd turn every one of these 90 degrees so that they ran between them. All the pipes ran between them. My kitchen space over here is in the same boat. The problem is I don't have enough space this way. So in reality, if I was going to build this, I'd do some rethinking and probably rotate this end of the building 90 degrees for its framing and put a support wall probably right here and maybe another one right here. And then run these horizontal this way and continue a wall right across to the middle there that support this up. So that's some of the things we have to consider when we do this. There's other things, but basically I want to make sure that I'm clear on what's going on in these pieces. You can see like I said, my footings and my stem walls in place. That's really pretty straightforward when you see it. It just gets detailed depending on what your bearing loads are. So that's the framing of our foundation in this case. It's just kind of a typical setup. It's not really detailed, and it hasn't been taken to an engineer to specify or anything like that. It's just a general idea of what goes on down there. So thanks for your time, and we'll get back to you again.